going, guys? So today I'm in Raleigh, but we pre-recorded the lectures so I can still get you guys the information. What are we learning about this week? Okay, immune systems. What are we learning about today? Thank you. So we're going to skip the quiz game. Lymphatic structure. So we're talking about the lymphatic system today. The lymphatic system is the parts of the body that protect it from antigens. The inflammatory response is inflammation of the body in response to an antigen. And lymphatic structures can be hard to spot because they're so small and only provide one part of the defense against the entire body. And much of the immune system involves chemicals and blood cells that can easily transport through different parts of the body. Antibodies are proteins that are created by the lymphatic system that fight off antigens to keep them from disturbing the body's processes of life. Lymph is a clear fluid transporting antigen-fighting cells and proteins through a network of vessels similar to blood vessels. They're about 90% water. They have other dissolved chemicals that supply nourishment to body tissues, and it is identical to plasma. In fact, it is plasma. The way that lymph gets into the lymph vessels initially is through plasma leaking from the capillaries when gas exchange is occurring, and then going into the lymph vessels at the capillary. Lymph nodes are made of groups of cells surrounded by connective tissue. The lymph follows the pathways through the body, starts out again in tiny lymphatic capillaries that are adjacent to blood capillaries. Then they go to the lymph vessels, they go to the lymph nodes located in the body's trunk, and that is where essentially the blood gets cleaned. The thymus is a gland located near the heart, a little bit above it, where T cells mature and learn what to fight and what to leave alone. In your teen years, the thymus actually begins to degenerate. So my thymus is not that large because I've already developed an immune system. And that's the point of it, is to develop an immune system for the rest of your life. And it is gradually replaced by fat cells. The spleen is the largest organ in the entire system, and B cells are made there, and they are the cells that make the antibodies. B cells and T cells both are actually white blood cells, different types of white blood cells. The antibodies eliminate bacteria and viruses. Oops. All lymph travels to one of the large veins near the collarbone on both sides of the body, called the subclavian vein, and here the lymph joins the bloodstream. Macrophages are white blood cells that fight antigens in lymph nodes by grabbing and holding on to antigens, and then they're going to take that back to the lymphatic system and give it to T cells. Lymphocytes are white blood cells that are produced inside bone marrow. There are two main types, B and T cells. And these stimulate the production of antibodies, although B cells are the ones that actually produce them. And so macrophages and lymphocytes are the two types, white blood cells. Lymphocytes have two types themselves, with T and B cells. Lymphatic function. Protection from antigens. There's something called passive immunity, and that is when someone is given antibodies from another organism. It doesn't last that long since the body hasn't produced them. And the most common way of obtaining passive immunity is from being born. So when you are born, your mother will actually give you a certain amount of passive immunity, and that is why if you look at a death rate per age, it will do something like a check mark. It will be a little bit high at first, and then it will rise as you get older. But that then sudden drop-off. Well, actually, excuse me, before it goes high, it's more like that. It'll be high at first because there's a lot of complications that could occur with pregnancy, but after you survive being born, that passive immunity will severely drop your death rate. Active immunity is when the body makes its own antibodies. Cell-mediated immunity is the immune process triggered by antigens where cells actually fight the antigens off. And these are where the macrophages and the lymphocytes come together to fight the antigens. Macrophages are non-specific. They'll just go around attacking anything and eating anything that they think is a threat. The T and the B cells specifically identify specific antigens becoming the kill-off. The process for antigens, for killing them. The antigen will invade the body. A macrophage, type of white blood cell, will engulf the antigen. The macrophage will then take the antigen to the lymph. A helper T cell, and this is where it gets confusing with different types of T cells and B cells, and they're all white blood cells, but we'll get through it. A helper T cell will transfer the antigen from the macrophage to a killer T cell, and the killer T cell will actually kill the antigen through what is called lysis, which essentially means cell death. After the killer T cell kills the antigen, it will create cytokines, and the cytokines are what kills the antigen. The helper T cell then tells B cells that recognize the antigen to make more B cells. And finally, memory T cells, memory B cells are created and sent out to kill other infected cells, and they will stick around for a long time in order to give you immunity for that disease. And that's why when you get a disease, you can have immunity for it the next time you get it. Autoimmune diseases are when a person's immune system cannot distinguish body cells from foreign invaders, and this leads to a lot of diseases like lupus, arthritis, diabetes, and allergies. Humoral immunity uses mostly B cells to fight antigens instead of T cells. And this can happen when the helper T cells captures an antigen as prisoner and signals the B cells to start making antibodies. So basically, macrophages will detect and engulf an antigen before a cell is infected. B cells make more B cells that are specific to that antigen. Helper T cells are used to signal even more B cells to make antibodies specific to that antigen. And the antibodies move with the lymph or blood to the place of infection. And the B cells make plasma cells, which create even more antibodies. Cell-mediated immunity takes place when an antigen is spotted by the immune system. Humoral immunity takes place in between cells and relies on fluids or humors. Both of them are called the body's primary response to an antigen. The secondary response is when the same antigen is encountered by the body again, and there are memory T and memory B cells to attack it. A vaccination is a type of active immunity in which it exposes a person to an antigen in the form of a pathogen to train the immune system to respond properly. The pathogen could be dead, could be weakened, and it can be administered orally or via a shot. For some diseases, people need booster shots to remind the body to produce memory cells and antibodies in order to produce memory cells and antibodies. Working with the rest of the body. The first line of defense is the skin. Other barriers to antigens which section it off, such as the blood-brain barrier and the mucous membranes. If an antigen gets past the skin, the immune response is triggered, and the lymphatic system is the interstate for the body's immune response, allowing cells that mediate the immune response and get there in time to kill the antigens. Muscles push lymph through the lymph vessels because the lymph vessels don't have a pump like the circulatory system. The bone marrow will produce the lymphocytes, and the bloodstream moves immune cells at times. The digestive system relies on the lymphatic system through lymphats. So a bunch of systems working together in order to make the immune response possible. So make sure you do your coursework, and I'll see you guys tomorrow.